today I'm going to be talking about and doing a walkthrough of a tool that we developed in partnership with Tableau software to visualize the 2018 sea level rise projections for Washington State. A link has just been provided to you in the chat window, so you can go and explore and sort of do a walk along with me here. Okay, so before I get into the nitty gritty of kind of walking through this visualization, oops, go back. See if I can go back. Just give me a minute. Got a little bit of a lag with the slide advancing here. There we go. Okay, so before doing a full live walkthrough of the visualization, we're going to take a step back and talk briefly about our starting point with these sea level rise projections and what really motivated the development of the Tableau Viz. So the screen you are seeing here is kind of the before. So previous to this Tableau visualization, in order to access the sea level rise projections for your area of interest, you would zoom in on this Google map and click on the blue circle that's closest to your area of interest or your site. Once you click on one of these blue circles, you'd be prompted with an Excel workbook that would download for this area. And each Excel workbook contained 2 Excel spreadsheets. So we have this spreadsheet that would download, which is the sea level rise projections that were generated under this low greenhouse gas scenario. And then you would also get another spreadsheet that was the sea level rise projections generated under a high greenhouse gas scenario. And so we have these spreadsheets for each of the 171 sites along Washington's coastline. And at the end of the day, that ended up being a lot of spreadsheets. And we found out very quickly that people do not love Excel spreadsheets. And there were 3 primary challenges with the spreadsheet. The first being that they're static. It was very hard for users to visualize change in sea level rise through the 21st century and beyond by just looking at static spreadsheets. The second challenge was that the spreadsheets really don't facilitate comparison between the 2 greenhouse gas scenarios easily. You kind of had to line them up on your desktop and toggle back and forth, which was challenging. And finally, there was no real clear takeaway message from the spreadsheets. If you wanted to get like a high level takeaway message for your site or for your project area, you really had to spend a lot of time with these spreadsheets and kind of wade through the data. And so the reason I highlight these challenges with the spreadsheets is those 3 factors are kind of what we wanted to achieve with the Tableau Sea Level Rise visualization. So the tool that we produced actually ended up developing 2 different ways to visualize the Washington State 2018 relative sea level rise projections. And both visualizations allow users to explore how the projections change through the time period considered, which is from 2020 out to 2150, for all of those 171 locations along Washington's coastline, as well as considering 2 different greenhouse gas scenarios. So here's a screen grab of visualization 1. I'm going to be doing a live walkthrough, so we're going to get into all the nitty-gritty details of this. But as a high-level sort of starting point, this visualization essentially allows you to explore different likelihoods for how much sea level rise could occur at different points in time. So an example question that you might present when using this visualization would be, how likely is it that we will see 1/5 of sea level rise by 2050 at this specific location that we've selected? So that's visualization 1. If we click, we'll go to a screen grab of visualization 2. So this is slicing the data in a slightly different way. So visualization 2 allows users to explore the likelihood of a given sea level change by a specific year. So we would be using visualization 2 to answer a kind of question like, when are we expected to see 1.5 feet of sea level rise at this location? Okay, so that's kind of my presentation bit, and now I'm gonna stop my sharing and transition over to our live walkthrough here. So let me minimize this and share that. Okay, So now you guys should be able to see my internet browser here. Here we're on the Climate Impacts Group website. If we scroll down, we get to visualization 1. This is basically the same thing of the screen grab I was just showing you. So our first task here is to select our location of interest. So you choose a location of interest within this Tableau viz by clicking on a blue line segment. So if you hover your cursor over these line segments, you'll notice that they're kind of popping out and highlighting. So each of these are a separate set of sea level rise projections. And we've built in a variety of different ways that enable you to navigate to your location of interest. So for example, we have the search toolbar up here where you can search for towns, cities, as well as zip codes. You can also use a more traditional panning feature where you can zoom in and out by double clicking using your scroll bar and your mouse. And dragging around. And we've also built in these sort of preset filters. So if you're interested in a specific county and you want to see all the line segments within a county, you just select that drop down. Let me reset it quickly here. And it'll bring you to all of the line segments within that county. In addition to the county filter, we've also built in this water resource inventory area filter in case that is the geographic scale at which you are planning for sea level rise. And there's a variety of options here as well. So for the sake of this example, I'm going to say that we're interested in looking at Olympia. So we'll throw in Olympia in our search bar, and then we select a specific line segment that we're interested in. When we click on it, we'll notice that our projections populate here on the right. So we've selected a location. Our next step that we need to do is select our likelihoods or our probabilities of exceedance. Again, this is the likelihood that sea level rise is going to meet or exceed a particular magnitude of sea level rise by a point in the future. So I want to emphasize that when we're selecting a probability of exceedance, the most important factor to understand is the level of risk that's associated with each likelihood here. And the decision of what likelihood you're going to check and explore is going to be an institutional decision. There's no quote unquote right answer here. It's going to depend on a variety of political, financial, and logistical factors that are going to be specific to each organization or decision that you're trying to make. That being said, we do present a variety of likelihoods that we can consider. So we have low probability of exceedance, which kind of range from this 1% to the 17%. These are low probability projections. These magnitudes of sea level rise are less likely to be exceeded. So I like to remember it as low likelihood, lower risk tolerance. So these are appropriate for risk adverse situations. In contrast, we can also look at high probabilities of exceedance. So these would be like from the 83rd percent all the way down to the 99th% probability of exceedance or likelihood. These are high probability probabilities of exceedance. These sea level rise magnitudes are likely to be exceeded. And so it's the shorthand I remember it with is high likelihood, higher risk tolerance. So if you're planning for these likelihoods or probabilities of exceedance, this is kind of a risk tolerant application. You're okay with flooding or sea level rise meeting or exceeding those values. When I'm exploring a site, I typically like to look at the 83rd percent probability of exceedance, the 17, we'll check there, the 50%, and the 1%. So now we've selected our likelihoods. So that was our second decision point. Now we need to move on to our greenhouse gas scenario selections. So the visualization shows relative sea level rise projections for two different greenhouse gas scenarios that are known as these representative concentration pathways. So right now we have both selected. If we look at our graph on the right, the high greenhouse gas scenario projections are shown in these shades of orange, and our low greenhouse gas scenario projections are shown in shades of blue. I find when you have both with multiple likelihoods selected, it gets a bit like a plate of spaghetti. So for the sake of simplicity, we're just going to look at the high greenhouse gas scenario for now. Okay, our final sort of customization feature that we have on this visualization is over here on the right. So here we have this slider bar that allows us to select the end year of the projection. So right now it's sort of maxed out at the year 2150. But if we're more interested in 2100, we just drag that slider bar to the left and our graph modifies itself accordingly. This isn't, if you are interested in designing for the year 2070, you don't necessarily need to drag this to 2070, as you can still see this time frame on your graph. Okay, so those are all of the decisions you pretty much need to make before really diving into the visualizations. So now we can see our visualization is basically divvied up into two sections. At the top here, we're looking at projected change in relative sea level rise for our location of interest down in Olympia. On our y-axis, we're looking at projected relative sea level change. This is in feet. And on our x-axis, we're looking at time. So because I've maxed us out at 2100, we're looking at sort of decadal time stamps through the end of the 21st century. And then our legend is showing all of the different likelihood curves that we've selected over here on the left. So our bottom one is our 83% probability of exceedance. We have our 50% probability of exceedance, our 17%, and our 1% probability of exceedance. These lines would change depending on what we select over here on the left side of the visualization. And also notice that we have this data table down here on the bottom. So this is showing the exact same data that's being presented in this line graph. It's just showing it in more of a tabular form. So we have our time column here on the left. We have our different probabilities of exceedance columns or likelihoods. And the various numbers in these cells here are just magnitudes of sea level rise in feet. So my favorite feature of this visualization is what we call this hover function. So if you take your cursor and you hover it over a data point in this line graph, it'll give you this little word box that pops up. This is what we refer to as a tooltip. And it essentially provides you with a very high level takeaway sentence for this data point. So I'll read a few examples. So for example, under the high greenhouse gas scenario, there is a 17% chance that the amount of relative sea level rise will meet or exceed 3.4 feet by 2100 at this location. And you may also notice, I can't show you with my cursor, but if you look down to that data table on the bottom, we're highlighting the year 2100, our 17% probability of exceedance, and we see that 3.4 feet, the cell that's containing that number is highlighted. So it's just showing us where in the data table we are. And the numbers within this tooltip change depending on what curve, what year, and what curve and what year you're looking at. If you prefer to look at the data table, you can do the same thing. Hover your cursor over a cell. It'll give you that tooltip sentence, and will also highlight the corresponding data point in that line graph above. So that's a high-level walkthrough of how visualization number 1 works. Now, if we scroll down on this web page, we'll get to visualization number 2. So notice that we have the same general layout as we did in visualization number 1. However, the big difference here is that rather than selecting likelihoods or probabilities of exceedance, we have the ability to customize different magnitudes of sea level rise in half-foot and 1-foot increments. So for this visualization, we're exploring the likelihood of a certain amount of sea level rise by a specific point in time or through time. So again, our first task is going to be to select our area of interest. So I'm going to use the same location again, just for consistency. So let's go down to Olympia. Got to click on our line segment. And once we do that, we're going to populate our graph and our data table here. So for an example, let's say we're thinking of designing for 1.5 feet of sea level rise, or planning for 1.5 feet of sea level rise at our site. And we're curious to find out how likely it is that we're going to see 1.5 feet of sea level rise or more at this particular location through time. So since our example is looking at 1.5 feet, we want to select 1.5 feet. You can add as many of these magnitudes as you want, but for cleanness and simplicity, I'm going to just do 1. So that's our decision there. Our second point we need to work down to is, again, this greenhouse gas scenario option. Since we only looked at the high greenhouse gas scenario last time, let's look at both. And now let's talk a little bit about these graphs and data tables on the right. So you'll notice that even though the layout is the same, the kind of shape of these curves is a little bit different. And the reason for that is because over here on our y-axis, we're now looking at the likelihood of seeing 1.5 feet of sea level rise, because that's what we checked over here on the left. through time, out through the year 2150. Again, you can modify that end year by using the slider bar over here on the right. And so these curves are showing the likelihood of us seeing 1.5 feet of sea level rise through the year 2150. Our two curves are because we've selected both a high and a low greenhouse gas scenario. So the red curve corresponds to the high greenhouse gas scenario, and the low curve corresponds to the low, or excuse me, the blue curve corresponds to the low greenhouse gas scenario. So that we see that for the first few decades, right, up to approximately 2050, there's essentially a 0% chance that we're going to see 1.5 feet of sea level rise. But as we move towards the second half, through the second half of the 21st century, the likelihood of seeing or exceeding that magnitude of 1.5 feet increases. And that's noted here in this tooltip. So let's go out to 2100 and compare. So under the low greenhouse gas scenario, we're looking at the blue curve now, there is an 85% chance that the amount of relative sea level rise will meet or exceed 1.5 feet by 2100. If we contrast that with the high greenhouse gas scenario, see there's a 90% chance that the amount of sea level rise will meet or exceed 1.5 feet by 2100 at this location. And as we move out towards 2150, the likelihood of reaching or exceeding that magnitude only increases. This is very easy to visualize down here on the data table, which again is showing that same data just in tabular form. And you can see again, if you highlight over a cell, it shows in the line graph above the corresponding points that we're looking at. So here in this data table, rather than looking at feet of sea level rise, we're looking at the likelihood of seeing 1.5 feet of sea level rise under different greenhouse gas scenarios. And so that is how visualization 2 works. The last thing I want to talk to you about is the various download features that we have for these different dashboards. So if you click this button in the middle down here, you have the option to download this whole, what we call a dashboard essentially. And this can be used to capture a summary of the data for your site that you can include in reports, send colleagues or clients, etc. You can also download the specific data that you've selected with our customization options. You can download this as a PDF. You can download a customizable PowerPoint slide. So there's a lot of different download options and customization features with this button here. Additionally, if you are very sad that we took away the spreadsheets, fear not, because we actually kept them. So you can download the full Excel spreadsheets, which is both worksheets for this specific location that we've selected here by just clicking on this little box. And so that will allow you to download all data for this site. It's not going to have any of the customization features that I talked about earlier, but it'll give you the entire data set. Thank you.